Hello everyone, I'm Xiang Li, and my teammate is Changwei Li. Our project topic is isolated bidirectional DC-DC converters. Here is our agenda. In this presentation, we will introduce abstract objectives, introduction, background, and design, approach, solution, some technical details, results and discussion, Gantt chart and future work. At last, our conclusion. The first part is abstract. In this project, we introduce the operating model and power characteristics. We use Simulink to conduct simulation experiments. We verify the correctness of theoretical analysis results, and we analyze advantages and disadvantages and the practical value of the converter. Our objective are introduce application of bidirectional DC-DC converters, theoretically analyze and formulate the mathematical model of isolated bidirectional full-bridge DC-DC converter in steady state, and we use the Simulink simulation model to simulate the working waveform and power characteristics of the converter and verify the correctness of the theory. At last, we analyze the working characteristics and control characteristics of the isolated bidirectional full-bridge DC-DC converter and analyze the advantage, disadvantage, and feasibility of the converter. Because of the unidirectional DC-DC converter can only realize the unidirectional transmission of energy, and it has certain defects in function. The isolated bidirectional DC-DC converter has the characteristics of electrical isolation and bidirectional energy flow, which shows unique advantages in many applications. So we design an isolated bidirectional full-bridge DC-DC converter in this figure. The topological structure of the isolated bidirectional full-bridge DC-DC converter is relatively simple, fast response, relatively small withstand voltage and current stress, so it's suitable for various occasions. This project mainly focused on the isolated bidirectional full-bridge DC-DC converter shown in this figure for research. Next, Changwei Li will introduce the simulation part.
Hello everyone, I'm Changwei Li. Let me introduce our design and simulation model. In this project, we have proposed two parts. One is the simulation and verification of the operation waveform and power characteristics under the single-phase shift control, the circuit structure. In the figure 1, the primary side and the secondary side of the converter are respectively connected to a constant power supply, and adopting single-phase shift control and driving the switching tube with a high frequency square wave with a duty cycle of 15%. The driving signal of the primary side leads to a secondary side with alpha phase. The voltage of the primary side, the full-bridge inverted is VA, and the voltage of secondary side of full-bridge inverted is VB. So the equivalent inductance voltage of the transformer T after ignoring the excitation is VL, and the current flowing the equivalent inductance is IL. And in the second part is to study the secondary side connection of the isolated bidirectional full-bridge DC-DC converter through the simulation experiments under the resistive load situation. Here is the MATLAB simulation mode we built based on the principle of the previous slides. The first part verifies the power characteristics, and the second part, which was the open loop circuit, will get a big problems. So because with an open loop system, the experimental value of the load output voltage and the output power will be much larger than the theoretic values. And there is a big error between the actual output and the expected value. So we propose to the closed loop circuit system. Here is what we built. Uh, uh, so the next slide, we propose the closed loop control. In the closed control loop system, the work of the converter is controlled by adjusting the phase shift angle, and here. So the fixed shift angle is not set, and it changes dynamically. Compared with the open loop system, the closed loop system adds a feedback loop. The feedback signal is different from the expected value, and then the deviation directly generates a control signal to eliminate the deviation, so that the final output is stable at the expected value, and the overall system stability is much higher. Here's what we built through PSW control to the PWM control. And then is a figure of the output we have get. From the first part, the variation part, the figure A, B, C, D are the drive poles of the different switching tubes. Those drive poles are high frequency square waves with duty cycle 50, and the waveforms in the figure A and the waveform in the figure C is 60 angle ahead of the curve, and the phase shift duty cycle is 1/3. The figure E waveform is 500 voltage, and the figure F amplitude of the waveform simulation waveform is 90 voltage, which is equal to the voltage of value V2 of the secondary side power supply. And the converted amplitude is N times V2. So the waveform is basically the same as the equivalent power supply Vs. And finally, the figure G and H are the equivalent inductance voltage VL of the transformer T and the current IL flowing through the equivalent inductance, respectively. The simulation images is consistent with the working waveform in the theoretical exercise. The results of the simulation experiments basically prove the theoretical exercise. From the part 2, here is what we get. We use SISO tool to adjust the PI parameters in MATLAB, and use both graph curves and frequency domain index to adjust the PI parameters. Finally, we select the two PI parameters. By using the designed DAB converter closed loop control system, we designed last page. For the simulation experiments results, it can be seen that the final load voltage and the current are stabilized at 38 volt and 11 amp, which is equals to the expected value, and the ripple is about 1 volt and 0.1 amp, and the final output is 449. Finally, let me we welcome the Xiangli to introduce the others.
I will continue to introduce the next part, technical details. Bidirectional DC-DC converter can change the current flow during operation under the condition that the polarity of DC voltage on both sides of the converter remains unchanged. The direction of energy transfer changes. Bidirectional converter in Figure 2 can transfer energy from U1 side to the U2 side with the same polarity, or it can transfer the energy from U2 side to the U1 side through current reversal. The anti-parallel structure in Figure 1 can obviously also achieve the same function, When the energy flows in the forward direction, the one-way converter 1 works alone, and when the energy flows in the reverse direction, the one-way converter 2 works alone, but it consists of two unidirectional converters. The topological structure is obviously more complicated, and the cost is also higher. Therefore, generally speaking, in practical applications, more direct selection of bidirectional DC-DC converter topological to achieve the effect of power bidirectional transmission. After that, we do the controller selection. By these three steps, first, we, according to the characteristics of capacitive element, we obtain the time domain relationship, and then we get the frequency domain relationship. Last, we obtain the transfer function of the control object. In this figure, we show the working principle. The voltage waveform Vp and Vs of the equivalent dual power supply and the current waveform of transformer equivalent inductance Ls can be found. In a working cycle, the converter will go through 6 working modes in sequence. In different modes, the working current will flow through different switching devices. Next is our main results. The simulation experiment results prove that the isolated bidirectional DC-DC converter using closed-loop control can basically achieve the expected voltage and power output. By adjusting the size of the phase shift angle, the power transmission is controlled to reduce or even eliminate the deviation delta UC of the output voltage, and finally stabilize the actual output of the converter at the desired value. Last, we compared with the open loop system. The closed loop system has a higher stability and higher feasibility in practical applications. This figure is our Gantt chart. We use about a month to finish our project. By this project, we learned the principle of isolated bidirectional full-bridge DC-DC converter. We researched the working characteristics of converter in the single-phase shift control mode. About future work, I think in a closed-loop control system, feed-forward control is designed to improve the dynamic response characteristics of the entire system, shorten the time of system dynamic adjustment, and we need to make the output reach a steady state faster. Last, we get the conclusion result by this project. We analyze the control mode and working process of converter by using the steady state analysis and mathematical derivation method. And we analyze the power of the converter in operation. Based on the simulation analysis, we verify that the theoretic analysis result and the practicability of the isolated bidirectional full-bridge DC-DC converter. Thank you. Thank you for listening to our presentation. This is our reference. Thank you.